Assalamualaikum warahmatullahi wabarakatuh. Today we will present about application of logic in real life, which is home alarms. Our group member first, Nur Kurutu Nasiha binti Muhammad Din, and along with me Titi Nurul Fakia binti Adnan, Nurjina Mirza binti Javazir, and Wan Nur Anisa Nazuha binti Wan Hashim. About introduction. So, what is mathematical logic? Mathematical logic is the form of representation, which is a branch of mathematics that uses a formal system to represent and analyze logical reasoning. Next, determine truth. It provides a systematic method to determine the truth or falsity of statements based on specific conditions. Next, propositional logic. To analyze logical operators in discrete mathematics, to analyze various situations and relationships. Last, decision making, to enable the creation of systems that can make decisions based on predefined criteria. So, why we use mathematical logic? The reason is, one, to ensure consistency and reliability. It provides a structured approach to decision making, ensuring that processes are stable and results are consistent. Next, to enhance system predictability allows engineers to design systems that respond predictable to various facilities. That the automation of complex process that would be impossible or too difficult to manage manually. Next, to eliminate ambiguity, to remove room for misinterpretation by establishing precise definitions and clear logical rules. Next, foundation of modern technology. It serves as the essential backbone for all digital circuits and computer systems, from smartphones to spacecraft. Last, real-world application. For example, it's used in home security system to ensure alarms trigger only under specific verified condition, efficiently preventing false alarms.
Shows a case study on how discrete mathematics and propositional logics are used in a home alarm systems. The system includes four main elements. A represents the alarm system being activated, D represents the door sensor, W represents the window sensor, and M represents the motion sensor. The alarm logic is A, N, D, or W, or M. This means the alarm will only sound when the alarm system is turned on and at least one of the sensors is triggered. This logic ensures the system works accurately and prevents false alarm when the system explains the input and output variables used in the home alarm system. The system uses four binary input signals. For the door sensor D, a value of 1 means the door is open, while 0 means it is closed. For the window sensor, 1 indicates the window is open and 0 means it is closed. For the motion sensor, 1 means motion is detected and 0 means no motion is detected. Lastly, the arm status shows whether the system is active, where 1 means arm and 0 means disarm. The output variable is the alarm. When alarm equal to 1, the alarm is activated, and when alarm equal to 0, the alarm remains off. The logical expression used is alarm equal to A, N, D, or W, or M. This ensures the alarm only triggers when the system is armed and at least one sensor is activated. Based on the truth table, when A equal to 0, the alarm will always remain off regardless of sensor activity. When A equal to 1 and at least one sensor detects a threat, the alarm is triggered. Overall, there are 7 out of 16 possible scenarios where the alarm is activated, showing that the system responds only when necessary and
Okay,
helps
next we
prevent
go to
harm.
logical connective. Basically, we have five basic connective, which is conjunction represent for and, dejection represent for or, negation represent for not, condition represent for implies, and biconditional represent for equivalent. In our system, we just use only two logical connective, which is conjunction and dejection or. For an operator, this symbol and mean both must be true. This is our safety log. The alarm only active if the system is armed and a branch is detected. Both conditions must be satisfied. And then for OR operator, this symbol OR mean at least one must be true. Must be true. In our alarm, we use it to connect our sensor, door, or window or machine. If any of this sensor is triggered, the OR key output branch detected. So our complete expression use both, which is A and in bracket D or W or M. So this is our alarm system logic. We have four sensor, which is D represent for door, W represent for window, M represent for motion, and A represent for up. But uh, D, W, and N, we use the sensor connect to a three input OR gate. And then the output of the OR gate connect to the one input of AND gate, and the ARM status, which is A, connect to the other input of the AND gate, and the AND gate output control with the alarm. Okay, so for logical equivalence, our original design also can apply in distributed law and De Morgan law. For distributed law, from original, it's gonna be after the equivalence. It's gonna be A and door or A and W or A and M. And after we apply to De Morgan, we can simplify that is the not version, saying it's not true that the system will disarm or
So
all
now we
sensor
move to
are
the
not.
problem solving. So our question is, will the house alarm sound based on sensor inputs? So the Boolean expression is alarm equal to A and D or W or M. So A stands for arm, where one mean active and zero mean disarm. D, W, M are sensor for door, window, and motion, where one mean trigger and zero mean normal. So our goal here is to ensure the system is both secure and practical with no false alarm. So now how do we solve this? So we break it into two clear steps. So the first step is to evaluate the R part. D or W or N. This is one if at least one sensor is active. Then the second part is the N part. A and with the OR result. So the alarm is 1 only if the system is armed and at least one sensor is triggered. So this logical structure is to ensure the system only activates when so it now should. We move to example scenario. The first scenario is house vacant and secure. So the input is 1000. Then it be 1 and 0 means the result is 0. So the alarm is off. So even though the system is armed, no sensor is triggered. So no alarm. Okay, for the second scenario is window open, system armed. The input is 1010. So the result is 1 means the alarm is on. So here the system is armed and a sensor is triggered. So the alarm sounds correctly. And for the third scenario is okay, for the third scenario is door open, system disarmed. So the input is 0100 and the result is 0 means the alarm is off. So even though a sensor is triggered, the system is disarmed. So this prevents a false alarm when the owner enters. So from this analysis, we draw three key findings. First, the alarm sound in 7 out of 16 possible input states. And the second is the end with A, X,
as a master switch to preventing a false alarms. And the last one is the R with DWM, ensure comprehensive detection
In
coverage.
summary, this project has successfully shown how discrete mathematics, specifically propositional logic, can be applied to develop a home alarm system. By using logical expressions, truth tables, and logic gates, we are able to understand how automated security systems make accurate decisions without human involvement. The logical equation clearly demonstrates how the system meets the required conditions for the alarm to activate only when necessary, helping to prevent false alarms. Overall, this example illustrates that mathematical logic is not only a theory, but also a practical to use in creating efficient and reliable technology systems.